Hello students. So today we are going to start with the basics for solving the AC theorems. So as we have in our previous lectures covered up the DC theorems that were Thevenin, Norton, maximum power transfer and superposition. So now the same theorems we will be starting with your AC circuits. So the basic difference between the DC symbols and the AC symbols are, you all have noticed that for the voltage source in our DC we use like this, and it is normally given like 10 volts, and the same thing when we use an AC is given by this sinusoidal wave sign, and we write the value of the voltage like this, where this stands for the angle and this is the magnitude of the voltage source. So next we all have seen that the current source is shown with the arrow like this, and we always write it like 5 amperes. The same symbol of the current source will be replaced by the same arrow but with this sinusoidal sign on this arrow that will indicate the AC current source. So that can be given like this also, or it can be given like this also. It can have any angle also, right? So the last thing is we use only resistances in our DC theorems, but when we talk about our AC theorems we use R as well as inductor, that is L, and we use the capacitor also. So it is always the case that when we talk about your resistance, we talk like 2 ohm, 3 ohm, 3 ohm, 4 ohm, 5 ohm, etc. But when we talk about your inductor or the capacitor, we talk in terms of the imaginary parts. Resistance consists of the real part while your capacitor and inductor consist of the imaginary part. The capacitor value is always given in the negative sign like minus J4 or minus J6 in ohms, while when we talk about your inductor, the value is always given in positive terms like J4, J6, J10 ohms. It is in positive. So now we are going to start with the conversions. So basically, when we go for the numericals on AC theorems, we are going to use the rectangular and the polar forms again and again, because we need to convert one form into the another and vice versa. So basically, when we talk about our rectangular form, it is always given in terms of a plus jb, or you can use a plus iota b. So that gives us a as the real part while iota b stands for the imaginary part. If we just see here, our a comes on the real axis while b comes on the imaginary axis. So when we talk about our polar form, it is always given as A angle theta, where A stands for the magnitude and theta stands for the angle. So when we have to convert from rectangular to polar or from polar to rectangular, your this A is given as under root of A square plus B square. If we want to know the value of this magnitude in the polar form, it will be equal to this thing. And if you just check out your this figure, if we are going to draw a diagonal like this, then our this value is going to be A, and the theta that it makes with the base will be the angle theta. That will be given by tan inverse of imaginary part divided by the real part. But when we go for your theorems, at least you require 5 to 6 times conversion from rectangular to polar and vice versa. So it becomes really impossible to convert it again and again. Moreover, for calculating your angle, you again require your calculator. So what we are going to do now is we are going to become familiar for this type of conversion on our calculator. So let's start. So now we are going to understand the conversion using the calculator by solving the two terms that we have taken in rectangular, and the same terms after converting into the polar form, we are going to convert them back to the rectangular form. So now let's start with 6 plus J3. So now in your calculators, you are going to find the words written as REC, that stands for rectangular, and POL, that stands for polar. You all can see on my the screen. So now what you have to do is You have to, because now you have to convert into your polar form. When you have to convert to your polar form, you need to press your polar. So here shift and polar. Now when you have to write 6 plus j3, you write it like 6 comma 3 bracket close and then equals to. So your this model gives you the value of theta and magnitude both on the at the same time. So here you can write it as 6.7 and angle 26.56. Here you can see from here, right? So now what we are going to do is we are going to change our this back to the rectangular form. So how we are going to type it, just see here. I am going to type rectangular now because the same thing I want to convert it in rectangular form. So it will be now 6.7 comma the angle 26.56 equals to. So now you can see that this is 5.99. So that is equivalent to our 6. And now the imaginary parts is 2.99 and that is equivalent to 3. So this 2.99, when you round it off, it becomes 3, and when you round it off, it becomes 6. So this is how you do the conversion. So now let's do the next conversion of 3 plus j4 into its polar form. So again, what you have to do is clear the screen because you have to convert to polar. So type polar and then write down 3 comma 4 equals to. So 5 and angle 53.13 will come at once. 5 angle 53.13 will come. So this is my polar equivalent. Now I am going to convert it back to its rectangular form. So now what I have to do is I have to type rectangular and then 5 comma 53.13 equals to. So you can see here that I am getting 3 and the imaginary part is coming out to be 3.99. So that is 3 and 3.99, which when rounded off becomes equals to 4. So this is how you are going to convert from rectangular to polar and back from polar to rectangular when you are going to solve the numericals. Now we will learn that why we require such type of conversions. So basically, when we talk about our rectangular form, we always use it when we have to add or subtract the two quantities. Like if I have got one term as 2 plus j4 and the other term as 3 plus j, then if I want to add these two impedances or I want to subtract these two impedances, I will be using my rectangular form only. But when I have to multiply or if I have to divide the two quantities, then my impedances must be in my polar form. So when we are talking about our multiplication, let's say my one quantity is a1 angle theta 1 and it is getting multiplied with a2 angle theta 2. How these two get multiplied in the polar form is a1 will be multiplied by a2 as such. Like if its value is 5 and its value is 10, it will simply be 50. The magnitudes will get multiplied as we multiply simple numbers, but the angles will get added up with polarity. It can be the case that my this angle is 90 while my this angle is minus 23. So that means with polarity means that it will be 90 minus 23. And if by chance this angle is 23, then it will be 90 plus 23 only. So with polarity, I have to take the value. Now when I am going to divide the two quantities, again let's say this is a1 angle theta 1 getting divided by a2 angle theta 2. Again I as we already said, that they will get multiplied as such. So similarly, a1 will be divided by a2 as such. Let's say the value of a1 is 10, while the value of a2 is 5, then this will become equal to 2. So what about this angle theta 1 and theta 2? In division, they both will get subtracted with polarity, right? So that means now we are ready to solve our numericals. So let's start with the numericals. So now we come on to our first AC theorem numerical that we have to do with our Thevenin's theorem. We have to find the current in our J5 ohm impedance using the Thevenin's theorem. So we will be solving as such that we used the DC theorems. So in DC theorems also, what we used to do is we used to short the voltage source for the calculation of our RAB. So here we have to calculate the value of the ZAB. So now shorting it down and then removing our RL value in which the current is to be calculated and naming these two terminals as A and B terminals. Now we have to send the current through our A terminal inside. So this gives me the combination J4 and J3 in parallel and then in series with J5, right? So here you can see that when the current reaches this point, it gets divided between these two paths. So that is why our J4 and J3 becomes in parallel. So now we need to solve our this rectangular and polar conversions to get the value of our this ZAB. Now always keep in mind that if we have got only imaginary term and there is no real term with this, then after converting it, it directly becomes as 4 angle 90 degree. And if we have got something in negative, like if we have 0 minus J2, it will become 2 angle minus 90. Let's cross verify it using our calculator. So it will be applicable for all the imaginary values like J4, J5, J10, whatever it is. So let's convert into polar. You have to feed the real component as 0. So here you go with your 4, then bracket, and this will give you 4 angle 90 that I wrote here. Similarly, now we can check for our negative sign. So again, we have to go for our polar value. So that is going to give me 0, comma, minus 2 is going to provide me with 2 angle minus 90 degree. So because there is only J4 and J3, so my this J4 will become equal to 4 angle 90, while my J3 will become equal to 3 angle 90, right? So what we need to do is we need to add them both. So this both will become J7, so that will give me the value of 7 angle 90 plus J5. This J5 will come as such. So now let's solve it as such. So 4 into 3 divided by 7, and the angles will be 90 plus 90 minus 90 because this is division. So this will get a negative sign. So then we have to convert our this thing into our rectangular form, and then we have to add with J5. So now this is coming out to be 1.71 angle 90. So now what we have to do is, because this is angle 90, that gives me the value of this as J 1.71, that we can cross verify from the calculator as well. So here you have to, because convert it into rectangular form. So I'm going to feed the value of, sorry, the real part is rectangular. So we have to go for our 1.71 comma 90, and here we get the value as imaginary 1.71 that I have just written here. So now we have to add them both, that gives me the value of 6.71 J. Right, so this becomes my ZAB. So I can jot it down here that my ZAB is coming out to be 6.71 J. Now the next thing that I have to calculate is my VAB. As I have told you earlier also, that after removing your load resistance, you have to move your pen from A to B point to know the value of your VThevenin. So when you are going to move your points from A to B, what you are going to find out is that VAB will be equal to the voltage drop across the J5 and the voltage drop across the J3 ohms impedance. So if you check here that from this 100 volts battery, there will be no current that will flow in our this J5 because this is open. So that gives rise to infinite resistance. So that means whatever current is going from here will go from J3 ohms only. So there will be no voltage drop across the J5 ohm. So that means we only need to calculate the current in the J3 and multiply it by that. So this will come out to be total voltage divided by sum of the two resistances, that is J4 and J3, that gives me J7 multiplied by J3. So let's convert it into the polar form. This becomes 100 angle 0 while this becomes 3 angle 90 and this becomes 7 angle 90. So this gives me 300 divided by 7 as the VThevenin. So that is equal to 42.86 volts. Because our angle this 90 and this 90 will get cancelled out for angle 90 minus 90 in the division form. So I will be left with only my this value, the magnitude value. So now I have drawn the Thevenin's equivalent circuit and I have put back my J5 in which the current was to be calculated. So now we can calculate IL because now this is my total voltage in the Thevenin circuit divided by the sum of the two resistances, that is 6.71 J and J5. So again we need to add them both and then convert to polar to divide them both. So let's write down the values. So now after solving, this gives me the value of IL as 3.66 because this when added gives me this value after conversion. So now we move on to our next numerical that is based on the Norton's theorem. So now we have to calculate the value of IL using our Norton's theorem. So this IL is 5 ohm. So we have to redraw our circuit to calculate our Zn now. So because this is a voltage source and this is also a voltage source. So this gives me my circuit as this because 5 ohm I have taken out. And so these terminals become the AB terminals. And this is my capacitor here and this is the short, so this is minus J2 and this is J3. So when the current will go from a terminal to inside this, it will get divided into two. So that means my Zn will be the parallel combination between J3 and minus J2. So now let's solve the parallel combination. So as I already told you that if the real part is not there, you can directly convert it into its polar form. So this becomes 3 angle 90, while this becomes 2 angle minus 90, this minus J2. Divided by J3 minus J2 will be equal to J only. So that becomes equals to 1 angle 90. So this gives me the value of 6 angle 90. That is the value of my Zn. So the next thing I have to find out is ISC by putting back my this and this source. So now for calculation of our ISC, you can see that we have shorted A and B terminals. When these terminals got shorted, now this current will have a path through this. Similarly, the current from here will have a path through this. So that means to calculate our total ISC, we need to add the current from the 10 angle 0 volts as well as the current from 5 angle 90 volts. So this is going to give me the value of 10 angle 0 divided by J3 plus 5 angle 90 divided by minus J2. So this becomes equal to 10 angle 0 divided by 3 angle 90, while this becomes equal to 5 angle 90 divided by 2 angle minus 90. Now let's solve it and get the result for ISA. So now this gives me the value of 3.33 angle minus 90, and this gives me the value of 2.5 angle 180. So when converted to its equivalent rectangular part, because this is angle minus 90, will give me the value of this only. So now let's convert 2.5 angle 180 degree into its rectangular form. So because I have to convert into rectangular, so I will be pressing the rectangular button, and then I will be feeding the value of the magnitude as well as the angle here. And the result is only minus 2.5. So this gives me the real part only. So I will be putting the value here. So now converting this thing back into its equivalent polar form. If you want, you can convert, otherwise you can take it, keep it as such. So let's convert it into its polar form. That will give me the value of minus 2.5 comma minus 3.33. That is the value of 4.16 angle minus 126.89. So this is the value of my ISC. So let's draw the circuit of the Norton's equivalent. So now we need to, I have drawn this Norton circuit, and now we need to find the current IL. So providing with the current division rule, we will be directly applying the formula. So this IL will become equal to total current given by 4.16 angle minus 126.8 multiplied by opposite branch resistance, that is 6 angle minus 90, and divided by the sum of these two impedances, that is 6 angle minus 90 plus 5. So let's convert them again. So now multiplying 4.16 by 6 will give me the value of 24.96, while the addition of minus 126.8 and minus 90 will give me the value of minus 216.8. Now we have to convert this rectangular form into our polar form. So here just mind it, because it has been written in the opposite form. Actually it is 5 minus j6, so we have to convert it into its equivalent polar form by pressing the 5 first. So because polar form, so it will be 5 comma minus 6, and the value is 7.8 angle minus 50.19. So this gives me the value 7.81 angle minus 50.19. So now we have to subtract these two and we have to divide these two. By doing this, we get the value as 3.19 angle minus 166.61. So this is the value of my load current that we needed to calculate. So this was my Norton's theorem. So now we come on to our superposition theorem, and this question is a homework for you all to do. You have to determine the current in 2 plus J3 ohm impedance. That is, you have to calculate this load current by using superposition theorem. Superposition theorem means there are two sources, so you will be considering your two cases. Case 1, where you are going to take only your voltage source and you are going to open this current source, draw the circuit again and find out the value of the current because of this thing, right? So it will be in the downward direction. So for case 2, what you will be doing is, now you will be considering your 20 angle 90 ampere current source, while you will be short circuiting, you will be short circuiting this 50 angle. This will be open circuit. You will be redrawing it, and then again it will be in the downward direction, and then you need to add both of them, and that will be the value of your total IL. So total IL will be equal to I50, the current because of I50, and the current because of your 20 angle 90. So this is a homework for you. That's all for now. Have a nice day.